Hello everyone. Very good afternoon to everyone once again. And today we are going to start about the hydrocarbons. So in today's class, we are going to discuss about few questions based on the hydrocarbon. Okay. And that question based on the NEET pattern and previous year NEET questions. And this hydrocarbon, this chapter consists of alkanes, alkenes, and alkynes. These three family members of the organic chemistry. So finally, how questions usually asked in the NEET from this chapter we are going to discuss. Not a very big deal. Few questions are related to the planarity based, few questions are related to the reaction mechanism based, few questions are related to the acidic and basic strength based. Okay, so we are going to discuss with all of these parameters, and one by one we will learn this question. So let's have a look. The first question. This is, which of the following can be used as the halide component? Question is strictly mentioned about the halide component. So you have to make an underline. It is about the halide component for Friedel-Crafts reactions. Okay. So in the Friedel-Crafts reactions, we have two types of reactions. First one is Friedel-Crafts alkylation. Second one is Friedel-Crafts acylation. Okay. So I just want to give you here. So there are two types of reactions: alkylation, Friedel-Crafts alkylation, and the second one, Friedel-Crafts acylation. Acylation. So in the alkylation, it can be Rx. Got it? And in the acylation, it can be RC double bond O, and this should be Cl. So this group must be there. This is acyl group. This is acyl group. If I have mentioned here CS3, so this will be the acyl group. Okay. So this question can be from the alkyl or can be from the acyl. So right now we have to talk about it. Which of the following can be used as the halide component? Okay. So chlorobenzene. It is mentioned that chlorobenzene, bromobenzene. Okay. So we are going to write one by one. Okay. So this is the chlorine and this is chlorobenzene. You can see here. And this will be the bromobenzene. So students, as you can see here, in this chlorobenzene and in this bromobenzene, there is these chlorine and bromine having the lone pairs. These lone pairs. These are the lone pairs. So what happened? These lone pairs increases the electron density of the benzene ring. And you can also say that there is partial double bond. So there is partial double bond character. Partial double bond character. Got it? So due to partial double bond character, they are not going to leave. Got it? If halogen is not going to leave, so definitely it is not able to proceed. It is not able to proceed the Friedel-Crafts reactions. So we have a very good conclusion that due to double bond character, double bond character, partial double bond character, they do not perform Friedel-Crafts reaction. They do not perform Friedel-Crafts reaction. Friedel-Crafts reactions. So it means, students, option A and B cannot be the answer. Okay. Let's talk about the option C. Option C is saying that chloroethene. Okay. So this is the CH2 double bond CH and this is chlorine. So what happened, students? This is a pi bond. It's a pi bond and these are the lone pairs. So what happened? This pi bond is going to break just opposite to the lone pair. Okay. So what happened? This carbon will get the deficiency of electron. So that's why this will be the help. So there is also double bond character. CH2, CH, and this is the Cl. So there is also partial double bond character. There is also partial double bond character. So there is also partial double bond character. Partial double bond character. So we can easily conclude it. It means this chlorine atom is not going to leave or not going to leave from the option A, from the option B, and from the option C. Last option, let's have a look what happens. So last option is isopropyl chloride. Okay, that's a very beautiful method. That is that this is the CS3, this is the CH, and this is the CS3. and this is the chlorine. So this is the isopropyl chloride. So what happens, students? You can see here, this is sp3 hybridized carbon atom, this carbon atom, because it is forming the 4 sigma bonds. So you can directly relate hybridization with the sigma bonds. So 4 sigma bonds, it is forming 4 sigma bonds. You can then conclude that 4 electron pair. If 4 electron pair, then you can say that hybridization should be sp3 hybridized. Got it? So that's why definitely this bond can be relieved, and this will form like this. This will be cs3, this is ch, and this will be the cs3, and this carbon, the middle carbon, 2 degree carbocation will be formed. So this is 2 degree carbocation formed. Carbocation formed and perform the Friedel-Crafts alkylation reaction, not the acylation, because right now we have the alkyl group, not the acyl group. So perform Friedel-Crafts alkylation reaction. Alkylation reaction. This one. Suppose that if you have students benzene, how we can say that Friedel-Crafts alkylation? So what happened? This is the benzene, and you know that benzene can break its pi bond any one direction. So it will perform this bond is going to break towards this end, or you can say that this bond is going to break, this bond is going to break towards this one, and this is the cs3 ch, and this will be the cs3, and there will be the positive charge. So what happened? This positive charge is directly attacked to this negative electron. This is the first step, this is the second step. So it will formed like this: ch cs3, this will be cs3, and this will be benzene. This will be benzene. But students, this bond is already broken, and this carbon will get the positive charge. So what happened, students? This electrophile attack to this benzene, then what happened? This carbon center also having the one hydrogen. So this hydrogen is going to break towards this carbon, and once again its aromaticity will come. So this will be ch cs3, and this will be the cs3, and this is the benzene. These two bonds will remain as it is like this, but due to this positive and this carbon will get the negative, so there is once again there will be bond. So this will be your compound. Okay, so what a beautiful compound that we have formed, and this reaction mechanism is known as the electrophilic substitution reaction. What exactly we have done? We have formed the electrophile. The step 1 was generation of electrophile, then the step 2 is attack of electrophile, and the step 3 is the cleavage of CH bond, that we substitute the electrophile by the help of H+. So there is H+ is relieving, and this H+ is combined with this Cl negative that is generating with this one and form the HCl, and your reaction will be completed. Very smooth process. I hope you enjoyed it. So this question we have done it beautifully. Let's go to the next question, and this is the next question. Yes. In which of the following molecules all atoms are coplanar? So what exactly the meaning of coplanar? Coplanar means all the atoms are sharing one single plane. Okay, so coplanar means all atoms are sharing same plane. All atoms are sharing same plane. So for these kind of questions, whenever this type of question is given to you, whenever this type of question is given to you, then I just want to suggest you find the hybridization. Got it? Because students, sp hybridization is linear, it's a planar geometry, and sp2 hybridization is also trigonal planar, it is also one of the plane geometry. But if you are getting the sp3 hybridized orbitals, it means it will be the tetrahedral. It means it is the 3-dimensional geometry, not lying on a single plane. So just find out the hybridization. So if you're going to get this one, suppose that option B. So option B is sp3 hybridized carbon atom. It means they having the 3-dimensional geometry. They are not on the plane. So this is not the our answer. Similarly, these are also sp3 hybridized carbon atom. Got it? So this is also 3-dimensional geometry. This will not be the correct answer. Similarly, you can get these are the sp3 hybridized carbon atom. Any one of the sp3 hybridized carbon atom, it means they are not sharing a single plane. Got it? So this is also three-dimensional geometry. So it means definitely it will not be the correct answer. But this question is very simply designed and very beautifully and very smartly. Let's have a look. This one I have just if you're going to choose any one carbon atom, so each carbon atom is sp2 hybridized. You can see this is sp2 hybridized. 3 sigma bonds. Each carbon is forming the 3 sigma bonds, sp2, 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 and this even this carbon is also sp2. Each and every carbon is sp2 hybridized. It means if each carbon is sp2 hybridized, so students, all carbons are sharing one single plane, and the geometry will be by the help of each carbon atom, that will be trigonal planar. Very simple geometry, not a very much big deal. You can also design like this. You can see here, suppose that this is the carbon, 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 carbon, and there is carbon. This is the biphenyl that I'm going to share, this one, and there is alternate pi bonds. Alternate pi bonds, and each and every carbon atom is, this is H, trigonal planar. You can see here H, this is H, this is H. These are on the same plane. These are on the same plane. This molecule is looks to be like this. Suppose that, students, this molecule is like this. Got it? But if you can see this molecule like this, like if you just tilt like this, then what happen? It will be on the same plane. Yes. So that's why, students, this is the coplanar. Yes, this is the coplanar structure. Coplanar, all atoms in biphenyl. Biphenyl. So this will be the correct answer. So finally, our correct answer is, okay, I'll try to avoid red color on the dark pages. Okay, so this will be our A answer, will be the correct one. I hope you understood this one. This A will be the correct answer. Clear to all of you? So not a very difficult question, very easy question, only hybridization based question, you can determine it. So hybridization you can discuss with the 3D geometry and the planar geometry. Let's move to the next question. This is in the given reaction. This question looks to be difficult, but not very much difficult. Organic chemistry sometimes looks to be difficult, but few basic things is going to be applied and you will get the correct answer. And most of the time students gets confused about the multiple rings. If multiple rings are present in the options, so they're just worrying about it there. So you don't need to worry about it. Just go with the procedure. You have HF is given. Then what happens, students? This HF. So first of all, I'm going to choose this one. Okay. So this HF, this bond is going to break towards this carbon atom. Okay. You can break in either side, left, downward or upward, because it is symmetrical. Okay. And in this one, there is H plus and there is F negative. So what happened? H plus is attack on the negative carbon atom. So this will be the H, and this carbon is getting the positive charge. This carbon is getting the positive charge. So what happened? What happened is, students, this is our electrophile. Act as electrophile. Act as electrophile. Electrophile. So it means if this alkyl electrophile and there is benzene, so it means the same process is going to be happen. What is the same process? Friedel-Crafts alkylation, we are doing it. Okay. So first we perform the addition reaction. So this step is addition reaction. Addition reaction. Okay. So and this one is, it is acting as an electrophile. So what happened? So this is the electrophilic center. This is the electrophilic center. So this electrophilic center is attack on the, this electrophilic center is attack on the negative side of the benzene. What is the negative side of the benzene? Okay. So just have a look. This is the benzene. And same procedure, students, that we have done it. This bond is going to break towards this one. Got it? So it will form like this. It will form like this. It will be positive. It will be negative. So on this negative side, this will attack. On the negative side, this will attack. There is H and there is positive. So what happened? It is coming and attacking on this negative side. And it looks to be like this. There is benzene. These two bonds remain same. And on this negative, it is attacking like this. Got it? And it will be like this. And this one. And this is H plus. You can see. There is H. And I'm not showing H. This H is just inside the carbon atom. Okay. So this H can be hidden. This H can be hidden in the bond line formula. So I'm not going to show this H1. Okay. So what happens, students? There is positive charge and this carbon having one hydrogen. So what happened? This hydrogen is going to leave. The same processes happen. Electrophilic substitution reaction. So what happened? It will be, there is benzene, this one. These two bonds remain same. And this is the cyclohexane. And then this carbon is getting the positive charge. This carbon getting the positive charge. And this carbon will get the negative. So positive, negative once again form the bond. So this will be the correct answer. Okay. So finally, correct answer is option C, this one. I'm not showing this hydrogen because hydrogen can be hidden in the bond line formula. So don't confused about it. Okay. Yes. So final answer is option C. It is also a kind of the electrophilic substitution reaction. And another name is Friedel-Crafts Alkylation reaction. So in the above reaction, we followed electrophilic substitution reaction, electrophilic substitution mechanism, and performed Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation reaction. This one we have done it. So let's go to the next one. Okay. So next question, let's have a look. Next question in front of you. This is the ethyne. Okay. And so many things is given to you. So don't worry about that. What will be the question? 2016, very recently question that we are going to do. So right now, students, I just want to tell you, ethyne is a weak acid. Ethyne is a weak acid. Why I'm saying this one? Don't worry about it. Let's have a look. This is HC, triple bond CH. If you're going to determine the hybridization of each carbon atom, so this is the sp hybridized. This is the sp hybridized. Sp hybridized means 50% S character. If 50% S character, and you know that electronegativity of carbon is directly proportional to the S character. So electronegativity of carbon, electronegativity of carbon is directly proportional to S character. So S character is maximum 50% S character. So that's why these carbons are sufficient electronegative to remove the H plus. So these carbon atoms are sufficient electronegative in ethyne. Electronegative in ethyne to lose proton. And behave like acid. Behave like acid. This one. So let's have a look. This one like this. This is H. This is C. Triple bond C. This is H. It has ability to lose the proton and form the H C triple bond C, and this is the negative, and this is the H plus. But it's a very, very, very weak acid. It's a very weak acid. Very weak acid. So that's why to remove H plus, right now we are going to utilize a strong base. So NaNH2 is a strong base which is used to remove proton from the weak acid, weak acid. Then what happens, students? What will be the reaction? So this will be CH, or you can say that CH triple bond CH, and if you are adding here NaNH2, let me erase this one, let me use different color. CH, C triple bond CH, and if you are using the NaNH2, then it will be broken CH. This is HC triple bond C, and there is Na. Got it? There is Na. It should be NaNH2, and there will be negative, there will be positive. And then what we have to do? We have to react with the CH3CH2Br. CH3CH2Br. So what happens, students? This bond is going to break towards this one. So this negative will this bond is going to break towards the bromine, because bromine is more electronegative. So this carbon is attack on this negative carbon atom, and it will form HC triple bond C, and this will be CH2 CH3 and form the NABR. So it means, students, this is the first process. So this will be your X, and X is your 1-butyne. So finally you formed your X. X is your 1-butyne. Got it? So you can find out which option. So option B and option C can be the answer. Got it? Right now option A will not be the correct answer. We confirmed that option A cannot be the answer. Option D cannot be the answer, because X is our confirmed, that is 1-butyne. Let's talk about the Y. In the Y, students, once again we have to perform the same reactions. We have to react this 1-butyne with the NaNH2, which is a very strong base, and once again it will remove its proton, and then we have to pass through this one. So let's have a look what will be our correct answer. So right now this will be our CH3 CH2 C triple bond CH. This is our X, and we are treating with the NaNH2. Got it? And in the presence of liquid NH3, it is a mixture. And then what happened? Once again, this bond is going to break. This bond is going to break towards the carbon, and it will form CH3 CH2 C triple bond C negative, and this is the Na positive. This one, and ammonia will be formed. Got it? Right now, once again, we are going to react with the CH3 CH2 Br, and this bond is going to break towards the bromine, because bromine is more electronegative, and this carbon getting the positive charge, and this positive carbon, this is the first step, and this will be the second attack on this one. So what will be formed? CH3 CH2 C triple bond C, then CH2, then CH3, and release the NABR. Release the NABR. So finally we got the answer. That is, if you're going to do the IUPAC name, then students, you can, this will be our longest chain. Got it? And this will be 1 2 3 4 5 6. You can either start counting from the right hand side also, because it will be the same. So this is hex 3 ion or 3 hexine. So both will be the correct one. So finally our hexine is third position. So what will be the correct option? Correct option you can see here in this board. 3 hexine is in the option C, not in the option B. So finally we have done the correct answer, and this will be our correct answer, option C. So beautifully we solved this question, wonderfully. So let's have a look to the next question, what we are going to do. Okay, so finally the next question is, which one is the correct order of acidity? So once again this question is coming from the correct order of acidity. So the same concept that we just followed immediately in the previous question, hybridization. If you know the hybridization of carbon, it means you can determine the percentage of S character in all the molecules. Got it? If percentage of S character will be maximum, then carbon atom will be more electronegative. If carbon atom is more electronegative, it means it is attracting the shared pair of electron from the hydrogen. It means definitely it has ability to leave the hydrogen. If it has ability to leave the hydrogen, so it will behave like the acid. Right now we have to find out which one having the more ability to leave the hydrogen and easily leave the hydrogen comparatively in all the molecules. Okay, so let's have a look. So once again, before going to this one, I just want to give you the general form. Okay, this is the alkyne, this is the alkene, this is the alkane, general form. If you're talking about the alkyne, this is HC triple bond CH. This will be the HCH double bond CH H, and this will be the HCH H CH H, and this will be the H. So I have taken the ethene, ethene, and ethane molecule. Got it? Its hybridization is sp. Its hybridization is sp2. Its hybridization is sp3. How I have determined the hybridization? I have just calculated the sigma bond. In the alkyne, there is only one sigma bond is forming by the carbon atom. Got it? So sorry, two sigma bond. One sigma bond with the hydrogen and one sigma bond in the triple bond. Two sigma bond. Two sigma bond, two electron pair, two orbitals. Means first one is S and second one is P. In the alkene, you can determine carbon atom is forming the three sigma bond. Two with the hydrogen and one in the double bond. Three sigma bond means three electron pair. Three electron pair means three orbitals need, and three orbitals means one is for S and two is for P. So sp2 hybridization. Similarly, sp3 hybridization. If you are calculating the percentage of S character, so that is very simple. How many orbitals of S? 1. How many total orbitals? That is 2. If you want to calculate the percentage, multiply with the 100. That will be the 50%. In this percentage of S character, then how many orbitals of S participating in this? 1 orbital. Total orbitals, that is 3 into 100, that will be 33.33% of S character. In this one, percentage of S character, if you want to calculate how many orbitals of S participating, 1 orbital. Then total orbital 4 into 100, that will be 25% S character. So you can see here, students, in the alkyne maximum percentage of S character. Got it? So that's why maximum, this carbon atom that is present in the alkyne, that will be the most electronegative carbon atom. If it is the most electronegative, so definitely it has more ability to lose the proton. So this will be the alkynes are the most acidic. So you can see here, directly connected, maximum percentage of S character, and in this minimum percentage of S character, and then if it has maximum percentage of S character, so most electronegative carbon atom, most electronegative carbon atom, and in this least electronegative carbon atom. If it is least electronegative carbon atom, if it is most electronegative carbon atom, it means most acidic, and this will be the least acidic. So finally, we have a general order. We have a general order for the acidic strength, and that is the alkynes, then alkenes, and then alkanes. So right now, students, just have a look. Right now, go to the option. So if you're watching the option A, alkyne, sp hybridization, wonderfully. Then it is also alkyne, then alkene, then alkane. So according to this, option A should be the correct answer. Got it? But don't directly tick the option A. Got it? Go through the rest of these options also. This should be in your habit. Okay. So the next one, there is alkyne. Definitely it is the correct one in the option B. But there is alkene and then alkyne. No, it won't be the correct one. Then option C, alkane, then alkene. No, it is just reverse order. Then alkene and alkane, alkene, alkene, then alkyne. Absolutely not. So finally, we got the option A is the correct answer. Beautifully, we solved this question, and don't worry about that. But right now, students, you confused about it, sir, how you have chosen that this and this, how you are differentiating these two. This can be your doubt, how you are differentiating these two. So I just want to suggest you, students, alkyl parts are the electron donor parts. Got it? If you're providing the electron to the carbon, then what happens? Carbon's requirement fulfilled. Of carbon's electron requirement will be fulfilled. When carbon's electron requirement will be fulfilled, then it is not going to attract the shared pair of electron from the hydrogen. So its acidic strength or losing proton ability will be decreases. Clear, everyone? So that's why we can differentiate it. Got it? So more alkylated alkyne is less acidic than the less alkylated alkyne. So more alkylated alkyne, and similarly for the alkene and the alkanes. Alkylated alkyne is less acidic than less alkylated alkyne. Alkylated alkyne. This one. So I hope you enjoyed all these questions, and this is the strategy of the NEET, and not a very difficult question. Even options are not very much close. You can see B, C, D can easily eliminate. Got it? We have not need some extra effort. So I just want to suggest you stick to your NCRT, prepare it very well, do all the questions from the NCRT, and then go to the any other reference books. So and the next question, let's have a look. Predict the correct intermediate and product in the following. So right now we have to perform. Students, once again, it is going to leave. So right now, students, for this question, H2O, H2SO4 and HgSO4. So in this procedure, if you are choosing this CH3, this is C triple bond CH, and if you are adding the H2O, so this is HOH. Got it? If you are adding the H2O, then it will perform the Markovnikov rule. Got it? So this will be the negative, and this bond, it will form the 2-degree carbocation. So this will be CH3, C double bond CH, and it is getting the positive, it is getting the negative. So what happened? On the positive side, this negative will attack. On the negative side, this positive will attack, and it will form the CH3 COH, CH3 CH CH3 OH, and this is double bond CH2. So this is enol form. Enol form. So right now, students, there is confusion. What happened? This is enol form, CH3 COH double bond CH2. So this is enol form, and after the tautomerism, there will be tautomerism. So what happens, students? Due to the tautomerism, this bond is going to break towards this one. So this carbon will be in the deficiency. So these lone pairs are going to help. So it will looks like this: CH3 C, there will be double bond O, there is H, and there is CH2, and this carbon is getting the negative, and this carbon is getting, this oxygen is getting the positive. And oxygen is the most electronegative atom, getting the positive charge. It means highly unstable. It wants to lose its positive charge and break the bond from the hydrogen. And this hydrogen, this is the first step. This hydrogen will attack on this negative carbon. So this is the shifting of hydrogen from within the molecule. So this is a tautomerism process. So this will be CH3 C double bond O CH3. So this is your X, and this will be your Y. So finally we solved this one. Okay, so X and Y, we have done it, and your final answer is, this is the process, that is tautomerism, and your final answer is option. This is X, enol, and this is Y. Or you can say that this is A and B. You can name it like this. This will be A and B, and this will be A in terms of X and Y. You can name it A and B. A and B. So we have done this. Option C is the correct answer. So thank you so much for watching this YouTube session, and do hard work. Got it? Do hard work with the smartness. Okay? And you will be more smart by the hard work. So don't forget this one. Okay? So thank you so much. Bye-bye, everyone.